Hello, this is Dr. Harrington, and today we're on lecture 17, page 13. So a company has decided to manufacture a new product. They predict that the demand function for the product can be modeled by this equation. Express the price per unit P as a function of quantity Q. So this is actually not too bad. The first thing we're going to do is we start off with the equation that we're given, which is Q is equal to 240 minus 2P. And what we're going to do is we're going to solve for P. So the first thing I'm going to do is bring the 2p to the other side, so I'll have 2p plus q is equal to 240. I'll subtract the q from both sides, and I'm going to get 2p is equal to 240 minus q. And if I divide both sides by 2, I'm going to get p is equal to 120 minus 1/2 q. Or another way of saying that is just negative 1/2 q plus 120. So now that is going to be my price equation in terms of quantity. Now if I want to find revenue in terms of the quantity, remember revenue is always going to be the price times the quantity. Well, we know what the price is now. So the price is going to be negative 1/2 times Q plus 120 times Q. So that's going to be equal to, well, let's see here, that's going to be equal to negative 1/2 Q squared plus 120 Q. Okay. So the next question says, find the marginal revenue. Now remember, this is a fancy way of saying the derivative of R, of the revenue. So I'll make a note of that. Note that the marginal revenue is going to be equal to the derivative of R with respect to Q. Now in the first case, again, you're going to bring this 2 down, so that turns it into minus 1. That just turns into minus q. And the exponent is going to be 2 minus 1, which is just 1. And the next one is just going to be the coefficient in front of the q, so that's 120. Or another way of saying that is just 120 minus q. So now we have to plug in these different q values and interpret what they actually mean. So let's go ahead and do that now. So when q is equal to 60, let's see what happens. When q is equal to 60, we're going to have the derivative of the revenue function evaluated at 60, which is equal to 120 minus 60, which is equal to 60. Now what this says is that revenue is increasing. I know it's increasing because it's positive by $60 per 1 unit. Alright, now let's see what happens when q is equal to 120. When q is equal to 120, then the derivative of r, put in 120, is equal to 120 minus 120, which is equal to 0. So it's not really increasing nor decreasing, it's remaining with 0 rate of change. This is interesting because this is going to be, and we'll see this when we take a look at the next couple slides, but this is what we call a turning point. Right? Because let's see what happens if we pick something bigger than 120. Then Q is equal to 200. And in this case, if I put in 200 here, I'm going to have 120 minus 200, which is equal to negative 80. So on this side, revenue is decreasing. by $80 per unit. Now let's think about what's happening here. If you pick something smaller than 120, it's increasing. Pick something bigger than 120, it's decreasing. And so that special point at 120 is what we call the turning point. Now, remember, when the derivative is 0, that indicates that we could have a max or a min in some cases. But look at this. If just visualize this for a second. Here, it's increasing when it's, so if I have 120 here, it's increasing on the left of 120, it's 0 at 120, and then decreasing after 120. So that tells us actually that the function is maximized, or revenue is maximized. Maximized when Q is equal to 120.